Hello everyone and welcome to lesson 21, hypothesis testing, this time with two means. So this first example just has some numbers, doesn't really have a story behind it, so we can go through the basics. So group number 1 had 32 people, they averaged 4.3 on something, and you also need to know their standard deviation. And for group 2, they've got a sample size of 35, a mean of 5.1, standard deviation of 1.4. So using the 98% level of confidence, so I'll write that down over here, 98% confidence. Test the claim that the two groups have the same mean. So that means that the mean for group number 1 equals the mean for group number 2. And then H1 can't have an equals, so I just cross out the equals. And then that tells me that my graph is going to have two tails. And then H sub O always has equals. All right, now since there's two tails, that means there's a critical value on the left and there's a critical value on the right. And when you're dealing with means, that means, double meaning of means, that means that we're using the t-distribution. Now when we use the t-distribution, we need to know degrees of freedom. And degrees of freedom is n minus 1. One small problem though is, that's an n and that's an n. And the rule is, whichever one is smaller, that's what you use for the degrees of freedom. So here the degrees of freedom will be 32 minus 1. So degrees of freedom is going to be 31. Now this one said to use 98% level of confidence, so that means that this is 98%. And usually I would go through and write the alpha equals 1 minus 0.98. You could also just say, well, if you take 100% and subtract 98%, that leaves 2%. And that means that this side has to be half of that, so 1%. And this has to be 1%. That way you get 98, 99, 100%. And then use the calculator to find the critical value. So use distributions right here, second distribution. And this time, it needs to be number 4, the t distribution. So we're using t, we're using t. And I will find this one right here. So the area right here on the left tail is 0.01. The degrees of freedom is 31. And then paste, and once you hit enter, it says that it equals a negative 2.453. They almost got them in order. 2.453. And on the other side, it's the same number except positive. 2.453. Okay, that's a 3. And now for the test statistic. So sometimes, let's say that I forget. I've been doing this so often that I don't, but let's say I forget what to use. Then sometimes what I do is just go through the list and look, what could it be? Well, I know that it has to have 2. And then when we're dealing with means, it's t, so it has to say both 2 and t. So it's going to be number 4, the 2 sample t-test. And so use the 2 sample t-test and now type in the information. So first of all, they put them in different order in the calculator. So first of all, the x bar is 4.3. And then the S is 1.2. And then the N is 32, and that's group number 1. And then go to group number 2. The X bar is 5.1. The S is 1.4. And the N is 35. And then this has not equals, so this should have not equals. Now on this part that says pooled, always say no. So this is something from several years ago that statisticians stopped using, but the TI calculator still has it in it. So always say no on the pooled. And then calculate. And the test statistic is t equals a negative 2.517. And now it's time for the conclusion on this one. So a negative 2.5 does go past a negative 2.4. That means we did prove something. So that means that the H sub O is false, because the H sub O was saying that the two groups are equal. And this is saying, no, they're not equal. So in fact, this group does better. Well, I don't even know what the situation is, but the mean is bigger. And now this is proving it in general. So in general, group B is better. But technically, the claim was that they are equal. So that claim is false. They are not equal. All right, and then on to the second example. So this example, I actually Googled up and found some interesting data. If you compare in and out, and this is just the basic worker, not managers or regional managers, just the basic workers at in and out compared to McDonald's, who makes more money? So then I found a data set with 44 employees at in and out. They were making an average of $15.52. And this is not just in California. So this was, wait, is there in and out other than California? Well, anyway, they're making $15.52, and McDonald's, there was 38 employees and they're making $13.20. So it definitely looks like in and out pays better. I would much rather make $15.52 than $13.20. But is 44 people and 38 people enough to prove it? That's what we're going to see. So test the claim that in and out, in other words, group one, pays their employees better than McDonald's. So the claim is that the average for in and out is better or bigger than it is for McDonald's. So group one pays more than group two. And then H1 cannot have an equals, and this doesn't. So that means that it's pointing to the right. So it's a right-tailed test. And I can even put that on my graph right now. There's going to be a critical value on the right. And H sub O, oh, sorry, I already wrote H sub O. H sub O always says the two are equal. Okay, with this one, it doesn't say what to use for the level of confidence. Like on the last one, I had put 98%, but this one doesn't say, so that's when we use 95% level of confidence whenever it's not given. And then that means that this side of the graph is 95% of the graph. That means the other side needs to be 5% of the graph. And like on the last one, when I go to do degrees of freedom, I have to do the one that is smaller. So the n that is smaller. So that means that degrees of freedom will be 38 minus 1, also known as a 37. All right, now use the distribution. So first turn the calculator on, and then go second distribution, and use number 4, the inverse t. So I can basically do it either way. I'm just going to say that this is the area, 0.95, and degrees of freedom is 37. And then it says that the critical value is 1.687. And since this number is on the right side, it is supposed to be a positive. Look at what happens if I do the inverse normal and I put the 0.05. Excuse me, I use the inverse t. And what if I had put the 0.05 instead of the 95? So then it gives me a negative number, but a negative number would be on this side, which is wrong. So if that happened to me, then I would just say, oh, calculator, looks like you made a mistake because that's supposed to be a positive 1.687. But what's happening is the way that TI programmed this calculator, whatever number you put right here for the area is actually what's on the left. So on the left side was the 0.95. That's why it gave me the correct 1.687. All right, now we're ready to do the test statistic. And just as a reminder, that's going to be the 2-sample t-test. And so go to stat, over to test, do the 2-sample t-test. And group number 1 is in and out. That was $15.52 per hour with a standard deviation of 1.03 based on 44 employees. And then for McDonald's, that's $13.20 with a standard deviation of 1.12, and that was based on 38 employees. And this over here is pointing to the right, so this over here needs to be pointing to the right. And pooled, always say no. And then just go down to calculate, and we just need to know what t equals, a 9.707. So t equals a 9.707. The cutoff is 1.6. 9.7 goes way past that. So that's definitely bigger than the 1.687. That means we definitely did prove something. So the H sub O says In-N-Out and McDonald's pay the same. That is false. So the H sub O is false. And then the original claim says that in general, In-N-Out pays more than McDonald's. So it turns out that yes, this is enough to prove it. The claim is true. So In-N-Out does pay more than McDonald's.